nice introduction. My name is Svetlin Stanchev, and one thing Paul forgot to mention was that I actually presented the first Android topic back in 2009, June 2009, just in the San Diego Java users group. Then the group was hosted at the UTC, at the Oracle Sun Microsystems office. And then there were very early days, but since then, as you can see, I have maintained my interest in mobile development in general and Android in particular. So I run a consultancy business. I have several subcontractors, and what we do is consult on interesting, more difficult than usual Android and web services projects, and also we help startups whenever they need to make a prototype to get financing through A series or in any other possible way, mostly with technical expertise. This is my email. The company name is Objectist.com. It's not Objectist. We don't object with object meaning we work with objects, sometimes even with subjects. So that's my LinkedIn. And today I'll be presenting to you the Couchbase architecture, which has been developing pretty rapidly for the past several years, and which I used in one of my recent projects. So it is a highly technical topic. That's not an intro to anything. Don't be afraid if you get about half of it. You'll have the slides and also video recordings to go through if it is an interesting topic for any of you. The agenda. First, we will describe which is the problem to solve, which problem are we trying to solve with this technology. Then, what are the application areas this technology is best suited for. Then we will go to an overview of the Couchbase architecture. Then we will drill down a little bit into some Couchbase Lite notion. Couchbase Lite is the mobile part of the entire architecture, and it has specific notions which you might not have heard about. That's why we will consider them a little bit more. Then we will try to demo an example mobile app which uses this architecture and concepts. We'll have then app code review, resources, and final Q&A. At some point, because it's kind of a long presentation, we'll probably have to take a break, right, Paul?
At 8 o'clock?
For about 5–10 minutes, yeah, 8 o'clock. I hope to be able to go to the example mobile app before. I will hope to cover everything but the example mobile app and the app code review until 8 o'clock. And then we will start from there. Any questions so far? Please ask me, interrupt me at any time. I enjoy being interrupted. Okay. All right, so what is the problem that we're trying to solve? The problem is that different applications have different requirements for data synchronization. And based on certain criteria, we can categorize them into three major groups. So based on the data location, which the applications have. What are their network requirements? Are they going to be available at all points or not? What's the responsiveness of these applications? And what is the enabling technology that makes all of these goals attainable? First category of apps is the remote-only app. There are examples of those. The older video players, for instance, some of the instant messengers, if they are not written in a particular good way, you have to be connected, otherwise the app does not know what to do. There are no data locally stored on the device in order to undertake any sort of work. So these are remote only. The requirement is obviously they have to be connected always. They are sometimes available because if you don't have connection, they don't operate fully. Then the responsiveness also depends on the network connectivity and the fact that even though they might implement some sort of data caching locally, they still need to ping quite often the server. So depending on the network speed, they might be not as responsible as even to be usable. And then what is used for, post-enabled technologies are usually web services or REST services, and the protocol is usually JSON. Then there are the local only. There are many. A local editor that you write to put that you use to put some notes. There are many of those. These are like the more primitive apps. People have thought that they can get richer with those and started producing a huge amount of those. After a while, they saw that that's not a reasonable business plan, but still there are a lot of those. So they are always available. They don't need connection. Well, they sometimes need. For instance, if you are using some sort of authentication to a server, you need to log in somewhere, get some key in order to unlock some functionality or something similar. And then they are always fast, obviously, and they are using some sort of a local storage, which is usually SQLite, which is a SQL type of a lightweight database which comes pre-installed on every Android device and every Apple device and every mobile device. And then there are the local and remote ones. They just are occasionally connected, have to be always available, of course. They have to be always fast because of the fact that they have some storage that they are using locally. So even though they are not connected at this point, they should be operational for most of the work occasions. And then, in order to make all possible, they need to use a notion of sync. Now, this is where the things start getting interesting because people understand under sync different notions and different capabilities. Most of the applications that are nowadays on the markets, what they use is a sort of either push mechanism to get data from the server, that which might be push notification in one of the cases, or they use pull from the client. And there are several scenarios in order to implement this sort of a synchronization between the local and the remote data. For example, the client the mobile client, the mobile application will know that some of the screens need to be populated with fresh data in order to stay up to date. And then what we see is a very annoying behavior. You click on the application, it decides at this point it has to refresh, and then you start waiting and waiting, and there is something rotating and running, and this means that at that point the client has realized there is a discrepancy probably between the server and the client and starts to synchronize in real time at this point. That is not a good user experience, as you can see. So most applications use this, and also they implement some sort of a periodic push. Whenever something is happening on a server, they try to push on the device, if that device is awake at that point. So this is, by the way, how, okay, let me not go forward. So, any questions again? No. So, what are the application areas which we're interested in and which is going to be the topic of my presentation? We are again talking about applications that are synchronized at all points, in real time, transparently. So we would like to have instantaneous, transparent, two-way data sync between the mobile client and some server. And that is important. That the user does not need to hit refresh, go on a specific screen, or any action. It has to be absolutely transparent to the user. It will look like as this application is always connected to the server and has all of the up-to-date data. Then it has to have the ability to work offline. You go on a plane, you have no connection, and you then just go off the plane, out of airplane mode, and then something magically happens and your device is up to date. But while you're on the plane, you can still work, you can do some changes, and then some magic happens, and the changes that you have made locally while you have no connection get negotiated between the live server and the device that just got online. So we want this as well. In order to achieve this, we need to be able to resolve data conflicts upon going online. Say, especially in a collaborative environment, somebody has pushed something and you decided to work on an airplane or whenever you didn't have connection for some reason, and your changes of the data is contradictory. So there has to be a mechanism for resolving these conflicts. Also, if that is possible, there will be a guaranteed consistency between the client and the server view. There will be no no overwriting of data on either side. And so we don't want the user to undertake some changes on the mobile device and then they will be wiped up by the server. We don't want that. So this is not a good way to synchronize data, obviously. It has to be also efficient and lightweight, which is a major challenge because we have to do some sort of pull and push in order to enable the sync. The underlying technology will have to rely on this. However, this means that the processor and the background services that are needed to run on the device use resources. And there is nothing more annoying, especially for a business user, and we'll talk a little bit more about that later on, when our application, which he is using, does something in the background, he's not aware of it, then he tries to make a phone call, and the phone call cannot be completed because the battery is low. That is something that they want to avoid at any cost, obviously. All right.
How's the battery life? Is it considered?
The battery life is considered, yes. Also, what is considered is the amount of memory. And what is considered is also how Android, in this case, considers all of this behind the curtain, behind the curtain's work. You might not know that. You might know that Android watches, observes the services, and if Android does not like any of the services, considers them too longer running or even too many resources, it kills them. And you can specify by defining them, starting in these background services which provide the same functionality as sticky or do some kind of tricks. But it's not always a good idea to rely on that. And also it's not a good experience if the user uses other apps as well, right? So we don't want your app to be just like some humongous thing that uses all of the resources. The user will notice this and they will start installing task managers to kill your app or uninstall it or do all sorts of things.
How do you enforce the consistency, like using some cache capability or some cache?
That's one of the main concerns. You're absolutely right. I'll talk a little bit more about this later. Don't want to go forward too much. Thank you. Okay, so this is the Couchbase architecture in general. The Couchbase architecture consists of several parts. This is the mobile clients. There are mobile clients on multiple platforms, as you can see on the picture. And then they use secure HTTP JSON in order to communicate on the mobile device to something called the SYNC gateway. The SYNC gateway is a prepackaged installation provided ready out of the shelf from Couchbase. It runs as a Unix process on a remote server. On the same server or on another server, there is a Couchbase Server, which is a NoSQL database, which is where actually the data lives. And also connected to the SYNC gateway, there is an option, there is a possibility to attach company-specific other servers, application servers, database servers. So the entire Couchbase architecture is meant not to replace any of the legacy systems, but to enable, to put something in front and to enable them to run in a more consistent, more user-friendly and also more secure manner. Again, the major parts are what is called Couchbase Lite, which runs on the mobile device, which connects to a SYNC gateway somewhere in the cloud, running as a Unix process. There is another Couchbase Server, which is a NoSQL database, just a normal database. However, it doesn't use SQL, it uses NoSQL. We'll talk a little bit more about this later. And also the SYNC gateway provides functionality when, for instance, we would like to have in the Couchbase server data extracted from an Oracle or other NoSQL or SQL database that is behind the firewall of the company that is using this architecture. So everything here in the green app server or whatever is It is basically what is the current infrastructure. So the Couchbase infrastructure builds upon and integrates whatever is currently available as well. The Sync Gateway. The Sync Gateway is a server that enables, it's a sync server, enables the Couchbase server to act as a replication endpoint for Couchbase Lite. So the Sync Gateway might have some caching over there, but usually its sole purpose is to put all of the messaging that goes back and forth together for all of the parts of the Couchbase architecture. The data itself is usually in the Couchbase server. So the Sync Gateway is this server that enables the other running process that provides the data access, the replication endpoint. And we are talking about replication because this is what sync is actually about. We replicate data in both directions, and if needed, we resolve conflicts. So it's basically a replication. It runs on HTTP listener process that provides a passive replication endpoint. So you can connect to it, it listens all the time, there is a listener process that has to be running at all times. And it uses a Couchbase Server notion, which is a bucket, and that provides the persistent storage. So the Sync Gateway does not provide persistent storage all itself. As I pointed out, it can communicate to backend, intra-company application servers, or any other entities through web services normally. It is provided as an appliance nowadays. Back 1 year ago, when we were developing the application that I will be using as a demo, they still didn't have an appliance for that, so we had to install our own Couchbase server and Sync Gateway, and we used Amazon Web Services for that. So if you'd like to, for some reason, not to use the prepackaged appliance and just configure it, but install it from scratch, that's also possible.
Is this Sync Gateway is a customized in-house module prepackaged installation? It's not a part of Couchbase.
It is part of Couchbase. So both the Couchbase server and the Sync Gateway are prepackaged installation packages that you can just run and install.
And is this Sync Gateway's similar scenario or structure, cloud or cluster environment? Like
Yes.
Cheaper and low that.
The Couchbase server can be used in cluster environment. It's actually how the whole Couchbase, if I may go a little bit out of the mobile area, I think that's going to be interesting for all of you. Couchbase started as a high capacity and high performance, always available cluster replication engine based on NoSQL databases, based on document type of model. So they started on the server side, and then they saw that a very good use case would be to actually provide data sync between mobile devices. So they used all of their experience. It used to be called Memcache, if somebody remembers that. They renamed themselves. It was one of the 3 or 4 most popular clustering and replication environments, but they've renamed themselves because they've expanded into more areas. So they have a long history of knowing what to do on the back end, and they've applied their knowledge into the front end right now as well. So you're absolutely correct. It can be used in a clusters environment. Usually there is one Sync Gateway and a cluster of multiple Couchbase servers, usually running locally or with a very short ping times in order to provide the throughput needed for all of the data to be synchronized. Remember, you can have hundreds of thousands, even millions of mobile devices of different kinds. So the Sync Gateway has to be very performant, very quick, and also the response, the retrieval of the data on the back end has also to be very quick as well.
So this is similar to like configuration clustering management center. They can balance multiple Couchbase servers.
Correct. Correct.
Second, what about the Sync Gateway? You mentioned that it's a moving process. That seems to be a bottleneck if you have like millions of subscribers accessing the same process.
Yeah. Well, I'm not aware of multiple Sync gateways. Currently, it might look like a bottleneck, but all we're talking about here is JSON object serialized, pushing both directions. So most of the time is actually spent retrieving the data, negotiating conflicts. So at this point, not at this point, last year there was not a feeling that that's a major bottleneck. But I went to the Couchbase conference in San Francisco back in October, and they showed a preliminary implementation of distributing the load on the server, on the C gateway as well. So they are working on this. I'm not up to date because that's not my latest project. I did this project about 1 year ago, and I'm presenting it right now because I was under NDA. I could not present it earlier. But this is all I'm talking about, you guys. It's just like classic stuff. It's not the cutting edge stuff that the current Couchbase is at. I will provide in the resources a little bit links around along these lines. The conference was free back in October. It was a 3 days conference, so everybody could just like attend it for free, and it was very, very useful, very helpful. They have a lot of new stuff coming up. Some in beta stage, some already in production. So, but I will just, in order not to get overtime, I can't get overtime. Okay. I will stick just to the standard, most classical use cases, okay? Okay, so the Couchbase Server is a NoSQL database with a flexible data model because it stores documents, not tables or any other sort of simple artifacts. It also maintains revisions of the documents that are stored in the database. And that's important because that is how one can resolve conflicts, comparing revisions, and also making a decision which is actually the more recent document or how did it change. So maintaining revisions is important. Has clustering capabilities, etc. And also there are appliances for it. At this point, I think that's all to know. We will look into the notions of more in-depth notions of the JSON documents a little bit later. Now, Couchbase Lite. Couchbase Lite is embedded. Couchbase Lite is whatever resides on a mobile device. It is a group of multiple entities. One of the entities is an embedded NoSQL database, which is installed just like the SQLite database, the normal SQLite database on the mobile device. It lives locally on the mobile device as well, but provides a different type of storage. Also, when one installs Couchbase Lite, which is the mobile part of the entire Couchbase architecture, one also installs a specific service, a background service that one needs, however, to configure. That background service is a very light one, written in a very efficient manner, and it runs constantly, and it is protected against being killed or somehow modified by the Android system. Whenever the device is rebooted, it receives the onboot completed broadcast from the system, so it restarts immediately after the device is rebooted. So it has nice properties which are not that easy to implement in the form of a lightweight service on Android, but the nice guys at Couchbase have implemented it for us to use. So it comes as part of the Couchbase architecture, this push-pull background service, but we still need to configure it. Currently, the embedded NoSQL database is a wrapper on top of SQLite. However, a pure NoSQL database engine has been introduced and it's currently in production. That is called 4SDB. I'm not going to talk about that one for now, nor am I going to talk about the SQLite. We are interested just in the wrapper, just the embedded database and how it's used inside the application. What's happening is data is written locally into Couchbase Lite because it brings low latency read-write access, very efficient, and also provides offline capability, obviously. So the user can use it, it's persistent storage. And then, upon going online, or upon other criteria fulfilled, the application that's using Couchbase Lite connects to the sync server, to the sync gateway, somewhere in the cloud, and replicates the changes in both directions between this database, the local one, the embedded Couchbase Lite database, and the remote sync gateway, which in turn uses the Couchbase server for persistent storage. The model is the same. Both of the databases are based on JSON documents, NoSQL database, and that is why the translation is very easy. Basically, it's their native format, so one does not need to transform the data from one format for transport and another one for storage. It's very clean and simple architecture. Okay, now, up so far, it was kind of probably quite easy, but now we are going to talk about some stuff that might not be immediately intuitively clear why the things are implemented this way. But for all of these notions that I have listed on the screen, when we go over the code, I will show an example of what this actually means and how it's implemented. So I will be jumping back and forth. Don't worry if you don't understand what's going on here. It is actually, that is my last slide before the break. And I will be spending a little bit more time on that in order just to have at least, to invoke at least some intuition about the basic Couchbase Lite notion. So, the top level Couchbase Lite object is called a manager. It manages a collection of databases just as a CouchDB server does. So the architecture is again similar. We have a top level Java object, which is called, it's a Pojo, I think, which is called manager. And then you invoke operations, create database, call database, etc. Then there is a database, which again is a NoSQL JSON document-based database. And you use the handle passed by the manager as a database in order to invoke operations on it, the basic CRUD operations. Create, update, delete. Inside the database, we have a document. A document represents a single database record or row in the form of a JSON object. So we are in the realm, not in the SQL databases, we are in the realm of the document-based databases. So a document represents a single database record, or in the SQLite terms, row. And it represents a JSON object. A document represents a JSON object.
So Svetlin, is it exposing the content provider interface? Is it using the content provider interface?
It is not using a content provider interface. No.
So it's a separate CRUD implementation for
Yeah, it is a sort of a direct implementation. Yeah. Funny that you ask. I had to implement a content provider for my latest project.
Yeah, why wouldn't we?
I don't know what their actually their latest developments are. I talked to the team in October. They tried to hire me. I told them that I'm not moving to San Francisco. So, and they mentioned that they need somebody actually to change something along these lines. One of their idea was to implement as a content provider. Then there is the notion also, possibly part of the content provider issue as well, is that currently the Android version is missing a data mapping model, meaning inside the code one operates usually with user interface, which is populated by an adapter for anyone who knows enough Android. This is how things work. And then, however, this adapter has to somehow be mapped to the JSON document. So there should be a model mapping for all of the, yes? Right. Okay. So these objects, oh, actually, I'll talk to this a little bit later on. So it's a natural idea, yes, I agree. They should have done it, in my opinion, as well. So for the
projections,
we cannot hear what you're saying.
For the mapping,
there is some notion of projection, yeah, for the mapping as well. Okay, so the next notion is a query. A query represents basically a view or a view-like resource. So basically, a query says, give me all documents that have certain properties. So these are not the SQLite queries. There is no query language as for SQLite. Although, again, back in October, they revealed a better version of a query language, which one can use for all sorts of business queries and providing reports, something that was missing so far. People who are accustomed to query languages don't want to go into all of this. They just want to query. Business analysts and people like that, they just want to be able to have a simple, straightforward language in order to produce reports in certain forms. That was missing from all of the JSON or NoSQL databases so far. It has been introduced last October, and currently I think it's in advanced beta, and they will be putting it in place and making it part of the standard Couchbase architecture installation packages very soon. So that gap has been filled in. Another more specific notion that we will see an example of, it's very important, is called a live query. So it's a query subclass that automatically refreshes the result rows. So in order for anything to work, and in order for the connection from the user interface to the persistent storage to work, something like this is obviously necessary, so that the user sees at all points the result of the updates that has been pushed by the server, correct? So the live queue query is exactly what provides this capability. It automatically refreshes the result rows every time the database changes by utilizing a listener. There is a listener defined on the database, on a document, and whenever it changes, the listener says something changed, and immediately whatever needs to be notified about the change or refreshed gets notified or refreshed. Then there is the notion of a module. That is where the pain entry point of Couchbase is currently, because the Android version does not have a model mapping between Java classes or model classes and JSON documents. So one has to write its own model transformer in the Android case. This is already available for iOS. And they've been talking for the past 6 months. And another issue that they are hiring people even currently, as far as I know, is to bring the Android version up to the iOS version by providing a model mappings implementation. And then the very important notion of replication. The replication, which we can think of synchronizing the views of the server and the client, or between the user interface and the database as well. But more often the first case. The replication is an object, again, all of these are objects, that we will see specific examples of those and how they are used. So the replication object is defined as a pull or push replication, and it provides obviously push or push functionality between the local and the remote database, and that one also needs to be configured.
So the configuration, I think you talk about Couchbase Lite on the mobile side and the Couchbase on server. How do you synchronize this? It means a lot of applications use a RESTful API or whatever, even for the listeners or for the synchronization or replication management. What APIs or what mechanism or problems behind this to do synchronization?
The transport protocol is HTTPS currently. They were talking about WebMD, I think, as a protocol, but currently it's HTTPS. The transport data format is JSON. Go ahead. Any other questions? Maybe back in the slides, because it's probably a good time to take a break right now before the demo.
Sure.
Any other questions? Yes.
Can you quickly tell us what the relationship is between CouchDB and Couchbase?
CouchDB and Couchbase.
Are they the same thing?
CouchDB is part of Couchbase. CouchDB Server, if you are referring to CouchDB Server, that is the server that has an underlying database, and that's called CouchDB.
Is that CouchDB in these scenarios is very unique characteristic compared with other NoSQL servers like MongoDB.
Yeah, MongoDB is mentioned as their direct competitor. However, this is the most advanced implementation currently. It probably is going to stay for a while because they have got a quite serious financing, and they have been normally the ones to go into other areas, for example, the mobile space. So this will be, they are currently the leaders, and they are probably intend to do so. I cannot compare the other synchronization and or NoSQL engines. I don't know enough to express any.
But what's the major reason to use CouchDB instead of NoSQL?
Instead of SQL or NoSQL?
NoSQL, like a MongoDB, and even like by the main pair, like maybe by the React Rabbit.
I don't know what's the reason from a general point of view. From the viewpoint of the project I worked on, none of those had anything comparable to Couchbase Lite. So the mobile part was either missing or in a very primitive state. So that was our only option.
I would say maybe the synchronization or the replication, all kinds of mechanisms are very well configured exactly for Couchbase. That's
Might be the case. Don't quote me on that. I don't know what's happening. Our only criteria was which one of the synchronization architectures was easy to use, NoSQL, and then had a significant mobile part. In March or April last year, that was the only one Couchbase. Okay.
Okay, let's go ahead and take a break. Let's meet back here about 5 after 8 o'clock. The restrooms are in the back. Pizza's still here and good. Hang around for part 2, the demo.
Paul, what do I